relaxed length. Now it is stretched by what amount? 5 centimeter. 5 centimeter it is stretched. Then what is the energy stored? What is the work required or energy stored? What is the initial energy? I can write down half k into x square. Okay, na? All of you following or not? Half k x square, where x value is equal to how much? X value is equal to 5 centimeter. X value is equal to 5 centimeter. Now further 5 centimeter we have to elongate. That means what? Already 5 centimeter is there and another 5 centimeter. Total elongation is how much now? 10 centimeter. That is the meaning of the question. Okay, that is the meaning of the question. So now it has to extend by 10 centimeter. Further 5 centimeter means. Now what is the final energy stored? So this is initial energy, final energy stored. What is the final energy stored is equal to half into k into, now I am writing 2x whole square, where x value is 5 centimeter. Or else you can write down half k into 10 centimeter square, half k into 5 centimeter square also you can write down, your choice. Just I am writing as 2x, that's it. Okay, na? So then it is half k into 4x square. If you want you can cancel out also, 4 and 2, your choice. Then they are asking what question is, you need to understand the question very well. Find the work required to stretch it further by another 5 centimeter. Means they are asking the work done from this position to this position. So is there any kinetic energy? No, only just we are extending the spring. So whatever be the work done by us, that will be stored inside the spring. I told you already. The work done by external agent will be stored as energy in the spring. Okay, na? So that means whatever be the energy difference is there, energy difference between the initial position and final position, that is called as work done. Okay, so work done is equal to what we can write down, final potential energy minus initial potential energy. So half k into 4x square minus half k into x square. So you will get half k into how much? 3x square you will get it. Now write down all the values. Half into k value. What is the k value? 5 into 10 cube. Multiplied with 3 times. 3 times of x square. Okay, now multiplied with the 3, x square is nothing but 5 centimeter square. So 25 into 10 raised to minus 4 meter square. We have to write down MKS in it. If you are keeping the 5 centimeter, then I think you might have got the different answer. So all values are in the MKS units, Newton meter. Okay, na? So you have to use the MKS unit only. So then this is 25 into 5, 125. Okay, 3 is there. So what is the best way? Okay, 125, 3 is 375. 375 by 2 into 10 raised to minus 1. That means 37.5 by 2. Okay, na? 37.5 by 2 is nothing but 18 point something. 36 is 18, no? So 18 point, how much should we get? 75, 150, no? Yes. 75, what? Newton meter, work done. Joules also you can write down, huh? Joules also you can write down. Work done in terms of joules. Okay, how many of you got correct this one? You remember the spring logic, no? Okay, Saitaja got, very good. What about remaining? No? Okay, let's write down fast because we need to discuss 15 questions. Write down faster. Or else listen to me and again we can try for that. So that is another best method. Okay, next question is this. Two blocks each of mass 1 kg are connected by a light spring of spring constant K. Spring constant is given. Initially velocities of the each block is given V0 and V0, which is equal to 10 meter per second. So initially blocks are projected and left. Then work done by each spring, work done by spring on each block up to maximum compression is. So as we have projected with V0 and V0, something like this. See, this block, both are projected with the same velocity. Same velocity V0 and V0. So then what will happen? spring will compress. Spring will compress and maximum compression. What is the meaning of maximum compression? Maximum compression is further it should not compress. That means velocities of the blocks should go to zero. Whenever velocities are zero, that's called as maximum compression, X max. We can call it as maximum compression. Maximum compression means further it cannot move. Blocks are moving together. Maximum compression means what? Further they should not go or they should not approach. If they are stopping there, then you will get the maximum compression. Am I right or not? If still block is going, compression will goes on. So try to understand that part. That little imagination is required. So that's why as the blocks are here, we projected in between spring, you can imagine, then spring will compress and blocks will go, somewhere velocities will be zero. That's called as maximum compression position. That means what happened here? The total kinetic energy is converted into potential energy in the spring. Then what is the work done by spring force or work done by spring? Work done by spring is equal to, I can write down, change in kinetic energy, because there is no force is acting. As it is compressing, as it is compressed, only spring force will act like this. Spring force will act and spring force will decrease the velocity of the blocks. Okay, so that you need to understand. So work done by spring is equal to change in kinetic energy. That only they're asking. Work done by spring on each block. They're asking up to maximum compression. Okay, each block they're asking. Let us see what is the change in kinetic energy. What is the final kinetic energy? Zero minus. Okay, minus of initial kinetic energy. What is the initial kinetic energy? Is half m v naught square, into 2 times. Final kinetic energy is 0. Okay, initial kinetic energy half m v naught square for one block. Like the 2 blocks are also having the velocity. So that's why I multiplied the 2. So finally what I'll get? I'll get minus m v naught square. So how much minus m v naught square? Mass is 1. V naught value is 10 whole square will give you minus 100 joules. But minus 100 joules is what? So this is the one place where I think you people made mistake. Some people at least. If you followed in this way, you got a minus 100. I think you kept the B answer. But minus 100 joules is the work done on both the blocks. Work done by spring on both the blocks. But what is the question? Question is on each block. Understood? That is the twist in the question. What is the twist in the question? What is the work done by spring? Work done by spring on both the blocks is minus 100 joules. But work done by spring on each block is required. Each block means by 2, you will get how much? Minus 50 joules. Okay, na? Understood the logic? You understood, all of you? Any doubt? Let me know in this question. This is the one good question. Like where you made a mistake, or I think where you people chances to go mistake. Anyone got the same answer? Shaiteja got, very good. How many of you kept minus 100 joules? Anyone is there? Work done by spring force is equal change in kinetic energy, because work done by gravity mg 0, work done by normal reaction also 0. Okay. Next, this is the next question. Okay, write down along with me. So they have given potential energy and displacement graph. They are asking the force and displacement graph. So 0 to A, x is equal to 0 here, x is equal to A. X is equal to 0 to x is equal to A. How the potential energy is? Potential energy is equal to some constant. It's y is equal to mx graph, no? Y is equal to mx graph. Mx graph is nothing but some constant, let us say k into x I can write down. K is some constant. It's linearly there. All of you observe? So there is a linearity. And graph is passing through origin and a straight line. So y is equal to mx logic. U is equal to m into x also you can write down if you want. So this is the potential energy from x is equal to 0 to a. Then what is the force value? And what is the force and potential energy relation? I told you that that is very, very, very important relation between potential energy and forces. Conservative and non-conservative forces, and how the conservative forces are related to potential energy or energy stored. I told you that is very important, and please revise again and again. Okay, so on that particular principle, basics, a lot of things of physics are involved in that. Huh? Yeah. What is the F is equal to? Minus du by dx, because moving along the same straight line, you can say. Then minus d by dx of minus kx, sorry, plus kx will give you what? Will give you minus k. K will come out. Derivative of x is what? So 0 to a, force is constant but negative value. Force is constant but negative value. That means force is constant, negative value. Yes, this is force is constant but negative value. So this option you can remove. Force is constant, negative value, you can take this option. Force is positive and constant value, you can remove this option. So from this you can remove the two options. Now let us go to the next step. For x greater than 0, sorry, x greater than a. For x greater than a, what are the potential energies? Potential energy is constant. If potential energy is constant, what the force value will become? The force value will become minus du by dx, which is, as potential energy is constant, force value 0, derivative of constant is 0. That means for x more than 0, x greater than 0, force is 0. So x greater than 0, force is not equal to 0 here. For x greater than 0, force is negative, and what do you say, that increasing. So this you can remove, and for x greater than a, force is, no force is there, force is 0, so C is the option. Simple. F is equal to minus du by dx. On that formula only I have given the question. Okay. Let us see the next question. So all of you listening now. So if you have question paper, again you solve that. Yeah, velocity and time graph as given of a particle of mass 2 kg moving on a straight line shown in the figure. So velocity, time graph. With the time, velocity is decreasing. Initial velocity is 10. At time is equal to 10 seconds, what the velocity is? Minus 20. Means velocity direction changed. So this is the time where velocity is 0. I told you this one also, turning points. Wherever speed will become 0, there particle will take the turn. So here negative velocity, here positive velocity, means this is one direction of motion, this is opposite direction of motion. Then work done by all forces. So this is only one term is enough to solve the question. What is the work done by all forces is equal to change in kinetic energy. Time is equal to 0 to 10 seconds. Time is equal to 0 to 10 seconds. We need to find out work done by all forces. Work done by all forces is nothing but change in kinetic energy. Work done by all forces is equal to change in kinetic energy. Okay. What is the change in kinetic energy? Half m into v final square minus v initial square. Half into mass is what? 2 kg into v final. What is the final velocity? Is minus 20. Minus 20 or plus 20 doesn't matter. Why? Because it's a speed. Kinetic energy we are finding. Minus 10 square. Initial velocity is 10. Initially 10, finally 20 for kinetic energy logic. Because kinetic energy doesn't require or doesn't see what is the direction of velocity. It is only magnitude. Okay, na? So half cancel out. This is for 400 minus 100 will give you how much? 300 joules. Okay, na? So A will be the answer. So direct answer. Very easy question. Once you know the work energy theorem, once you remember the work energy theorem. Still I can see so many videos are off. As usual, leave the video off. Hemant Kumar, Swarup, Satya Swarup, in no class you are switching on your video. Okay. Then force acting on a particle in a conservative force field Conservative force field is given. Find the potential energy as a function if it is 0 at origin. So I don't know how many of you solved this question. This is for this I told you also. Particle is moving in xy plane. Now tell me what is the relation between force and potential energy. Force and potential energy relation. I told you that dV is equal to minus F bar dot dr bar or ds bar, dy bar, dx bar, dz bar. You can write down anyway according to the context, according to the given context of question. Do you remember this? Du is equal to minus F bar dot dr bar. I don't know how many of you remember this, but it's a dot product. Then I have taken f dr cos theta. Then theta 0, I have told you one thing. Theta 90, I have told you some other case. Theta 180, I have given some other logics to analyze the situation, right? So case 1, case 2, case 3, I think so. So I don't know how many of you revised and remember. Okay, so now du is equal to minus of f bar. What is the f bar is? 2x I cap. Now I am not writing the theta, cos theta. Why? Because already they have given vector. If vector is given, no need to go for f into dr into cos theta. Directly you can go for vector dot product. If only magnitude is given, then you have to go for f ds cos theta logic. Magnitudes are given. Okay. So 2x I cap plus 3y square j cap dot product with what is the dr bar? Dr bar is nothing but it is moving in the xy plane. It is moving in the xy plane. So that's why I can write out dx I cap plus dy j cap also. This I told you also. If particle is moving along the only x-axis, then take dx. If particle is moving along the only y-axis, you take dy. Only z-axis, dz. If particle is moving in the xy plane, take dx I cap plus dy j cap, a small displacement vector. I'm talking about purely this dr bar or ds bar concept. Okay, na? If particle is moving in all directions, like 3D, if particle is moving in 3D, then take dx I cap, dy j cap, and dz k cap. Okay, so according to the context, you can change, or else here also you can take. Now you take plus dz k cap, that automatically goes to 0. Okay, na? Even if you are taking the dz k cap, so there is no use. That goes to 0. All of you understood this thing? How I am taking the small displacement vector? So small displacement along the x, small displacement along the y. Then what is the du value? Tell me what is the du value I can write down? Minus of I cap dot I cap 1, I cap dot j cap 0, j cap dot I cap 0, j cap dot j cap 1. I think you remember. Then whenever vector dot product you are doing, you just multiply the coefficients of I cap and multiply the coefficients of j cap. Multiply the coefficients of I cap 2x dx. Multiply the coefficients of j cap 3y square dy. Okay, na? So that means what the du value is equal to minus 2x dx minus 3y square dy. Now find the potential energy function. What is the meaning of find potential energy function? Now in the xy plane, okay, na? Now if I'm taking a 1 point x comma y coordinate, what is the potential energy at this point? That is the logic. That is the meaning of function. How the potential energy changes as x, y coordinates are changing. And moreover, they have given that, I told you, no, this also I told. If you want to define a potential energy at a particular point, then what is the required quantity? You have to define where is the zero potential. Without defining the zero potential, you cannot define the potential at any point. But you can define always potential difference. Hope you remember. This I explained a lot. So that's why they have given the zero. Zero at the origin. At the origin, potential energy is 0. So that's why what we do, we'll integrate. We'll integrate all the terms will integrate. Now these are the x terms, these are the y terms. So that's why 0 to x and 0 to y. Am I right? If you are moving from this point to this point, x coordinate will change from 0 to x. Y coordinate will change from 0 to y. And how the potential energy changes? Potential energy at 0, origin. At origin, potential energy is 0. Potential energy at this place is u. So 0 to u, you have to integrate. Okay, na? So then integral du is u. Okay, na? And where is from where to where? 0 to u is equal to minus of 2 will come out. x dx integration x square by 2 from where to where? 0 to x. It depends on simple logic, simple understanding. That's it. Integral y square dy. Then y cube by 3, 0 to y. So finally, what is the value you'll get? So in the place of variable upper limit u minus 0 lower limit minus of 2 into 2 to cancel out also. If you want, you can cancel out. Otherwise, 2 into this is x square by 2. In the place of x, x minus in the place of x 0, 0. Lower limit will be 0. So minus of 3 into it is y cube by 3. Now keep in the place of y upper limit minus in the place of y lower limit. All of you understanding? Any doubt, let me know. Then 2 and 2 cancel out, 3 3 cancel out. What the u value will become? Minus x square minus y cube. So minus of x square plus y cube. So D will be the answer. Okay, anybody got this answer? Saitej, you got a very good. Manish, Saitej, you got. Manish, you got? Saicharan, Manish, Teshwar Reddy. Bhavana, okay, Bhavana got. Nipere Jabbotna, Bhavana. Very good. Manish also got, very good. Nice. Hari sir unnada? Hari sir vachada? Leda? Hari sir leru. Okay, next. This is the next question. A constant power P is applied to a particle of mass m. The distance traveled by the particle when its velocity increasing from v1 to v2 is. Power is constant. And whenever something question is like this given, you can take, for assumption is what? Particle moves in a straight line. Okay, na? If nothing is mentioned about the path, either you have to see in the question something is given or not. If nothing is mentioned in the question and no other idea to define what is the motion of the particle, then you can take straight line motion. That is one default assumption you can follow. So that's why I wanted to avoid this straight line logic. Now power is constant. They're asking the velocity increasing from v to v1 to v2 distance value. Now all of you listen to this. Power value is constant. Okay, na? So power is equal to what we can write down. We can write down that f v cos theta, f bar dot v bar, f v cos theta, where theta will be what? 0, straight line motion. Velocity is increasing from v1 to v2. So then P is equal to, I can write down F into V. F is nothing but MA into V, I can write down. MA into V, I can write down. Okay, na? So now P is equal to, M into A value, dV by dt, I can write down, into V. But time is not required, no? We require the distance traveled, distance or displacement traveled, when velocity is increasing from V1 to V2. So displacement or distance should be there and velocity should be there, but time is not there in the question, time is not required. So time value we have to eliminate. To eliminate the time value, power is equal to m into dv by dx into, we can write down dx by dt, chain rule. See, is there any mistake in writing like this? No. Why? Because dx and dx will cancel out, you will get dv by dt only. This is called a chain rule, converting one derivative into two derivatives. All of you remember this one? Huh? So then what is the advantage of this one? The advantage is m into dv by dx as it is, but dx by dt we can write down as v, because x is the distance or displacement traveled. Okay, na? So x is distance or displacement traveled, so dx by dt will give you speed into v again. So now see, mass and power you can leave, those are constants. Velocity and displacement, equation is converted into velocity and displacement. Even yesterday or day before yesterday I told this thing. Whenever non-uniform motion is there, acceleration can be written as dv by dt, dv by dx into dx by dt also. Do you remember? So then the power is equal to what we can write down. Power is equal to m into v square dv by dx. Now we require the dx value, so that's why I'm writing as p into dx on this side, dx on this side, then m into v square dv. Now integrate. Velocity changing from v1 to v2, x value will change. Total distance traveled is 0 to x. Initial displacement or distance is 0, and finally it is getting to the v2 speed, v2 velocity, the displacement is x, total displacement traveled. Then p into integral dx is x, 0 to x, m into v square dv integration, v cube by 3, x raised to n plus 1 by n plus 1. So v1 to v2. So then p into x minus 0 in the place of variable upper limit minus in the place of variable lower limit. I think by this time you got it. M by 3 I am taking out, and this is v2 cube upper limit minus lower limit v1 cube. So finally what is the displacement or distance traveled? M by 3p into v2 cube minus v1 cube. That is the displacement traveled. Okay. So this is the what do you say, that easiest way. When power is constant, you can go with force, acceleration, again velocity, displacement, a lot of things are there. Okay, na? But velocity keep on changes, that you need to understand. Okay, finished? So what would be the answer? M by 3p v2 cube minus v1 cube. So this is C actually. Option C. Okay, na? So let us see the other questions. Yeah, this is paragraph. This is easiest question. I don't know how many of you identified this one is easy, but okay, let us see. So what they're saying, that there is a one spring. This is the wall, let us say. One end of the spring is fixed to the wall. Other end is kept to the block of mass M. Okay, this is smooth surface, no friction. As there is no friction, there is no tension. No tension for us. Easily we can do all the things. Now what they are saying is that there is a constant force acting on the block. A force of constant magnitude F is applied to the block so that it begins to compress the spring until block comes to a maximum displacement X max. Means we are applying the one force which is constant in magnitude. Constant magnitude, then what happens? Block will move forward. By what amount? Let us say X amount, it is moved forward. If block is moved forward by X amount, then what is the compression of the spring? X. X is the compression. And force is constant. And by the time it is compressed by X amount and block has gone to here, now block will get some velocity V, because it is not slowly moving. We are applying the constant force and pushing. Then block automatically will get the velocity. Not like the things what we have done in the theory part. In the theory part, I told you that block is pulled slowly. Spring is extended slowly. Spring is compressed slowly. But here it is not slow. We are applying the constant force. That can be any magnitude. Okay, na? Now, what they're asking different questions. During the displacement, which of the following curves shown the graph best represent kinetic energy of the block? And next, work done by the spring block system by the applied force. These are the things they're asking. Then what is the work done by applied force? Work done by applied force. It's easy. Work done by applied force is equal to, what you can write down? Work done by applied force is equal to F into X. Force and displacement both are in the same direction. So Fx cos 0, which is simply F into X. So work done on the spring block system by the applied force. So by applied force, what the work done is equal to? Work done is equal to F into X. And what is the kinetic energy of the block? Half mv square. And if it is displaced by x amount, what is the work done by spring force? Minus half kx square. So I can write down now, work done by all forces is equal to change in kinetic energy. Let us say work done by all forces. Work done by applied force is F into x minus work done by spring force minus kx square. I think all of you remember. Work done by applied force is half kx square. Work done by spring force is minus half kx square, because spring force and displacement are always opposite each other. So that's why work done by spring force will be always negative. So I don't know how many of you remember all these things. In the theory, I discussed all these points. Okay. So that's why listening the class is very, very important. Yeah. And what is the change in kinetic energy? What is the final kinetic energy? Half mv square. And what is the initial kinetic energy? 0. Initial block is at rest. Initial kinetic energy 0. So this is the idea. Okay, na? So that means half mv square. Kinetic energy of the block is equal to F into x minus half kx square. Tell me what is the graph? So half mv square. Kinetic energy is y. Kinetic energy and block graph. Kinetic energy of the block and what is a displacement during the displacement. Kinetic energy of the block graph we have to find out as a function of x. So kinetic energy on y-axis, x is on x-axis, then I can write down this is ax minus bx square. Do you remember the graph? Y is equal to ax minus bx square. A is ax minus bx square graph, which is projectile equation, projectile trajectory equation. Then graph should be something like this, x and y. The graph should be something like this. That means the graph is what? Third one. See, this is the third graph. Okay, na? So answer is 3. This is easy actually. I don't know whether you solve the remaining questions or not. This question you have to do. How? Work done by applied force only they are asking. Now, what is the applied work done by applied force is equal to? Work done by applied force is F into x. Is something like an y is equal to mx formula. Then how the graph should be? The graph should be what? Graph should be straight line and passing through origin. Straight line passing through origin is 1. So A should be the answer. Direct. Okay, location ready, very good. 3 is the answer for previous question. Okay, all of you understood? Work done by force they are asking. Next, what is the other question is? Other question is, which of the following curves show the best potential energy stored in the spring? What is the potential energy stored in the spring is? Potential energy stored in the spring is half kx square. Half kx square is the energy stored in the spring. Then if you are drawing the graph between potential energy and x, it is in the form of what? Y is equal to some constant into constant. I am writing as c. Y is equal to cx square. What is the graph? Y is equal to cx square graph. Parabolic graph. But only you have to take the parabola in the first quadrant, not in the second quadrant. So what is the graph is representing? 2. It's a parabolic graph. See once. It's parabolic graph. Okay, na? So 2 is the answer. Nothing to do. Only thing, one part, work done by all force is equal change in kinetic energy. That you have to write down. So now tell me how many of you got all integer correct, all integer questions correct? Bhavana got, very good. Bhavana. All integer questions correct. Okay. So this is the integer question. First question. A block of mass 1 kg start to slide down on a fixed inclined plane of inclination with the horizontal. Coefficient of friction between block and incline is 0.5. The rate at which mechanical energy dissipates. What is the meaning of rate at which mechanical energy dissipate? Dissipate means loss. I told you this also in the class. Whatever I'm explaining, okay, Manish, you got one wrong. Saichan also got one wrong. Okay. So dissipate means loss. Loss will happen because of what? Friction. That means rate at which mechanical energy lost. Energy rate means power. Energy rate. Rate is nothing but what? By time only, na? Energy by time will give you what? Power only. That means what they're asking question, they're asking that power lost by friction. So that is the question. See, indirectly I have given. If I give the power lost by friction, I think some people have done it, might have done it. So this statement you need to understand, rate at which mechanical energy is lost. Okay. That time is equal 1 second is required. So for that, what we have to do is, we have to see that how the block is moving. So block is sliding down already as given, block of mass m, then mg sin theta will act downward direction. Sliding down, I think mu mg cos theta will act upward, kind of friction. Remaining normal direction, mg cos theta will cancel out and will come down with acceleration a. Then what is the mg sin theta value? A is equal g into sin theta minus mu cos theta. I think all of you remember this part. Net force is mg sin theta minus mu mg cos theta. Net force is equal to, okay, let me write down. Okay, because already sliding down has given, so that's why. What is the net force is equal to mg sin theta minus mu mg cos theta. Then what is the acceleration value is? Acceleration value is equal to net force by mass. As it is net force by mass, mass will cancel out, g will come out, g will be there in both the terms. So g sin theta minus mu cos theta. So finally, what is the acceleration value? Acceleration of the block is, the acceleration of the block is equal to g into 10 into sin theta, sin 37 minus mu value is 1 by 2, 0.5 cos 37. So acceleration value is equal to 10 into sin 37, 3 by 5 minus half into this is 4 by 5. Okay, na? So ultimately this is 2 by 5, 3 by 5. It will be 1 by 5. So 10 into 1 by 5, you will get how much? 2 meter per second square. That is the acceleration value. So we are getting positive acceleration, means sliding down only. Then what is the velocity? Velocity at time 1 second. Release from the rest, no? Sliding down on flicks it down. Release from the rest only. Start to sliding down. Start to sliding down means start sliding down means zero velocity. So initial velocity is 0. So v is equal to u plus at, 0 plus a value, 2 into time. Okay, na? So v is equal to 2 into 1 will give you how much? 2 meter per second. Time value is 1. 2 meter per second. So then if velocity is 2, then we have to find out the power by friction. Power by friction means friction force also you have to find out. All of you understood the rate at which mechanical energy dissipate. Mechanical energy is losing because of friction only. So that means rate means energy by time will give you power only. So that's why power by friction they're asking. So what the power by friction is? Obviously we'll get negative. Okay, na? So minus of F into V. Friction is acting upward, velocity will be downward. Then what is the angle between the friction and velocity is 180. Then what is the power by friction is F into V into cos 180. Power is negative. That's why we are writing that lost. Okay, na? So then what is the power by friction is? Power by friction is equal to minus of mu mg cos theta is the frictional force into velocity. Minus of mu value 1 by 2, mass value is 1 kg and g value 10, cos 37. Cos 37 is 4 by 5 into velocity is 2. Okay, na? And 2 and 2 cancel out. 5 2s are 2 4s are 8, minus 8 watt. Power by friction is minus 8. That means lost is 8 watt. They're asking the loss, no? Loss means you should not say minus. So the answer will be 8. Already they are saying loss. That's why no need to write down the negative. All of you okay? Understood? So let us see the next question. Okay, so as I have to explain more number of questions, so I need to change the slide. So a man weighing 60 kg climbs a staircase carrying 20 kg load on his hand. The staircase has 20 steps. Each step has a height of 20 centimeter. If it takes 20 seconds to climb, then what is the power? Average power they're asking. Power is equal to total work done. Total work done by total time taken. That's it. What the total work done means? See, he has to climb. He himself has to go. At the same time, he has to carry the load of 80. I mean, total 20. Then what is the total mass he has to carry upward? Total mass is 80 kg. Am I right? So work done will be, I can write down mgh by time, because he is carrying against the gravity. Then what is the total mass is 80 kg. G value 10. What is the height value? 20 steps, each having the 20 centimeter. That means what the total height is? 20 into 20 centimeter. That is the total height. By time is 20. Then what is the value I'll get? I'll get 8. Okay, you can write down anyway. So 800 I'm writing. Into this is 400 centimeter. That means 4 meter by 20. Got it clear? So are we getting 160? No? Okay. So this is, you understood this thing, this is in centimeters, but we have to write down in terms of water. In terms of water, power in terms of water is nothing but MKS units. So that's why I have to convert into meters. 20 into 20, 400 centimeter, that will become 4 meter. Then 0 cancel out, 2 then you will get how much? 160 watt. But I'm asking in multiples of what? 32. So that will be what? 5. Multiple of 32 is what? 5. Anyway, location radius. I took like 20 into 20 centimeter. 20 steps, each is having 20 centimeters. So 20 into 20, 400 centimeter, 4 meter. Okay, you should not take the only load, you have to take the total mass. That is the other idea you need to implement. Okay, clear? This is the easiest question. They have given the velocity and under a constant force as given. They're asking the instantaneous power applied by the particle. So what is the instantaneous power is equal to F bar dot V bar. They have given the velocity and force both. Then what is the power value? Dot product between these two vectors. How to go for dot product? Multiply the coefficients of I cap. 5 into 1 minus 3 into 1 and 6 into 2. That's it. Power is equal to 14 watt. This is the easy question. I don't know how many of you did it. So 7x, x value is equal to 2. That is the required answer. Okay, na? Hope all of you solve this question. Next, again potential energy came, and they're asking find the magnitude of potential energy at the position where force is 0. Understood? We have to find out the potential energy value, but where force is 0. So ultimately we have to find out the force. We have to find out the force first, then we have to see that where force will be 0. Wherever force is 0, there you have to find out the potential energy. That is the logic of the question. First, let us calculate force. What is the force value? I can write down minus du by dx. Potential energy function is given, force they are asking. Then force is equal to minus of d by dx of u value. What is the u value is? 1 by x raised to 12 minus 2 by x raised to 6. So then F is equal to minus of d by dx of, the first term I can write down x raised to minus 12, minus of minus plus d by dx of 2 into x raised to minus 6. Okay, I have taken into the numerator. Now apply the derivative logic. Minus of x raised to n derivative, n into x raised to n minus 1, minus 12 into x raised to minus 13. Okay, plus 2 is constant, take it out. X raised to minus 6 derivative, minus 6 into x raised to minus 7. So finally, what is the force value I can write down? This is plus 12 by x raised to 13. This is minus 12 by x raised to 7. This is the force expression. Force changes with the x like this. But we have to find out the force is 0. Where force will be 0? So 12 by x raised to 13 minus 12 by x raised to 6 is equal to 0. Okay, so then, okay, you can go like this. 12 by x raised to 13 is equal to 12 by x raised to 6. 12 cancel out. Okay, then x raised to 13 is equal to x raised to 6, I can write down. X raised to 13 minus x raised to 6 is equal to 0. So just I want to see that remaining things. If I take x raised to 6 or 7, it's 7, sorry. This is 7, okay. So x raised to 7, if I take common, x raised to 6 minus 1 is equal to 0. So x value is 0, it can be x value what? X raised to 6 is equal to 1. So x is equal to 1. So x is equal to 0 also possible. So I think 0 or 1, any answer is possible. I have taken, I think I have given only one answer, right? So 0 also possible actually. Okay, x is equal to 0, force value is 0, because x raised to 7 into x raised to 6 minus 1. Either x raised to 7 is 0, okay, na? And or x raised to 6 minus 1 is 0. Both values are possible. No, I have taken only, I think, x value 1. So x value 0 is possible, even x value 1 also possible. Okay. So if I am keeping x value 0, it's infinity. So it's not the answer. Infinity is not the answer. X value 1 if I am keeping, then what is the potential energy value? Potential energy value at x is equal to 1. Okay, so answer you will get only 1, not 2 answers. So 1 by 1 minus 2 by 1 will give you minus 1 joules. So modulus will be 1. If you are keeping x value 0, then it will become infinity. So that's not the answer, obviously. So what is the other answer you have to take? X value 1. Okay, na? So I think that's why I have taken only x value 1. I didn't remember actually while solving. All of you okay? So at x is equal to 1, at x is equal to 0, both the places force is 0. So at x is equal to 0, but we are getting potential energy is infinity. So at x is equal to 1, potential energy is minus 1. I'm asking the magnitude. Magnitude means what is the answer? Answer for this is 1. All of you okay? Yeah, this is the next question. A particle of mass is given moving in the positive x direction. Actually, this is the graph as given. This is the graph. Graph is straight line. Its initial position x is equal to 0 and velocity at 1 meter per second, and the velocity at x is equal to 10 is 2v. What is the v value they are asking? Again velocity, but here power is not constant, power is variable. Power is variable, okay? Just a minute. Power is variable, variable power. So then how to calculate the velocity? As I told you previously, as this is variable power, what we have to do? We have to integrate it. So whenever graph has given, you can think from the slope or area under the graph. I don't know how many, whether I explained or not. Let us go with the area under the graph, because area under the graph will give you answer. So that's why I'm just going with the area under the graph. For the area under the graph is integral p into dx. You can check the slope. Slope is equal to dp by dx. So dp by dx, power by some distance. Power by distance, there is no quantity in physics. That's why no need to do with the slope. Just I'm checking that's why area under the graph. Area under the graph means integration. So integral, what is the power is equal to? I can write down f into v, power, moving in a straight line. So cos 0. So f into v is the power. So then integral m into, I can write down a into v dx. So integral m into a value I can write down dv by dx into dv by dt. dv by dt into v into dx. Same as previous power question, okay? So then integral m into dv by dt, I can write down dv by dx into dx by dt into v dx. Okay, na? So dv by dx into dx by dt into v dx. dx cancel out, dv by dt you will get it. So from this, what we can cancel out? We can cancel out the dx term, or else no need to do also. Okay, you can do in this way, or else you can cancel the dx term, or else here only you can manage. You see, integral m into, okay, na, dv into v into, I can write down dx by dt, no? There's no difference. Here dv by dt is there, that I'm writing as dx by dt. So the dx by dt will become what? Dx by dt will become again velocity. You understood the difference? So that is important idea. Important conversion here into v again. That means what is the area under the graph is equal to, m will take it out, v square dv. So area under the graph is equal to m into integral v square dv. Now we require from where to where? From x is equal to 0 to x is equal to 10 we require. Means what is the velocity? Velocity at x is equal to 0 is 1, and at x is equal to 10, what is the velocity? Is 2v is the velocity. X is equal to 10, 2v is the velocity. Then I can write down area under the graph. What is the area under the graph now? This total area. All of you following this thing? You understood the area under the graph? This integration logic you understood? So I think you felt this question is difficult in the examination. How many of you did this question? Anybody did this question? Now what is the area value? Total area value. Total area is equal to, you can take, this is rectangle area. What is rectangle area? Rectangle area is equal to 2 into 10. 2 into 10 plus this triangle area, half into base 10, height 2 again, is equal to, what is the mass value is 10 by 7. 10 by 7 integral v square dv from where to where? 1 to 2v. Okay, na? Here 1 at this end 2v is the velocity, so 1 to 2v velocity integrated. Then this is 20, this is 10, 30 is equal to 10 by 7. Okay, na? V square dv integration. V square dv integration is v cube by 3 from 1 to 2v. Okay, na? So 0, 0 cancel out. 3, 7, 21 is equal to v cube. In the place of v, 2v. So 2v whole cube minus, in the place of v, 1. So 1 cube by 3 I can write. 3 is there. 7 I have taken on this side. Okay, Lokeshwar did very good. Then this is 63 is equal to, this is 8v cube, 2v whole cube, 8v cube minus 1 cube is 1. 1 on this side 64, 8v cube. So then v cube is equal to 8. Then v value is equal to how much? 2. V value is 2, not 2 meter per second. Because 2v is the velocity. Yeah? 2v is the velocity, we require the only v value. So v is equal to what? 2 is the answer. All of you understood the area under the graph? Area under the graph logic is important here. All of you okay with this question? This is a good question. You try again. You solve this question again. Huh? Okay. So only Lokeshwar Reddy did. Okay. Understood all of you? So solve the questions whatever you left and whatever the questions you did mistake. Okay. So writing exam is not a big issue. Anybody will write down. Okay. If you give me exam, I'll write down any exam. You give me any exam, I'll write down. Writing exam is not an issue, not at all an issue, not at all a what do you say, the big thing to achieve. So what is our next steps? Writing the exam, getting a marks. That is the next step. So getting marks is a big thing. Not only getting the marks, and after examination, whatever mistakes you have done, analyzing the mistake will make you more successful towards your target. Okay, so if you follow analyzing your examination, then your success is unstoppable. Nobody can stop your success. But when after examination, you have to see that again, how you wrote the, how you solve the question, but actually how you have to solve the question, what questions you left, what questions you did mistake, where you have committed mistake. Okay, so learning these things are very important. Okay, na? Yeah. So all of you do it again. If you have still problem, let me know. Tomorrow we'll discuss. Okay, na? Yeah. Bye everyone. We'll meet you tomorrow. Tomorrow we'll discuss the circular motion. Okay, now once you revise the circular motion also. Okay, yeah, bye. Bye everyone.
Bye everyone. Practice. Where is Charan? He told some mistakes are there, sir, like that he called. Any mistakes is there, Maki?
No, sir.
Huh?
No mistake, sir.
No mistake. Lokesh. Manish, any mistake? Okay. Practice those
No, sir.
problems where you done mistake. Okay, bye everyone.